Good morning. This lesson is for my Honors Integrated 1 class. This is lesson 4.1, but before I get started, I want to say that I hope that everybody is doing okay out there. Let's go ahead and jump right in and talk about our goals. We have 3 goals today. Our first goal is to define what we call a sequence in terms. The second goal is we're going to be finding terms using an explicit rule. And our third goal is going to be about additional observations about sequences and relations. Okay, so let's just go ahead and jump right in. A sequence is a list of numbers in a specific order. Because in order there's a first, a second, a third, that's what we're talking about when we're saying a sequence. Now, each number in a specific order, that's called a term of the sequence. And we normally write sequences in tables. So I have a table right here. And notice I have an N and an F of N. I'm not using an X and an F of X, I'm using an N. You can think of N as the number of term, which term number. So we don't use X in this, we use N. So my numbers across the top are my N numbers. These are my inputs. I have a first term, which is 8. I have a second term, which is 16. I have a third term, which is 32. I have a fourth term, which is 64. The numbers with the N, we're going to call these our position numbers. Okay? And then the position numbers tell you where they are in the order of the sequence. These are our terms. So the statement that I have right here is telling me that my third term is 32. All right, so sequences can also be written in sequence notation. So again, I have an N, this is my position number, but instead of saying F of N, I say A sub N, sub being subscript. They're really interchangeable. I'm saying the same thing right here. I'm saying that the third term is equal to 32. Right? So this is the exact same thing. The third term is 32. So again, these are my position numbers. This is the term value at that position number. Okay, I'm going to check off a sequence. Remember, a sequence is a list of numbers in a specific order. And when things are ordered, they have a first, a second, a third. We don't ever have a 0 or anything when we're dealing with sequences. There has to be a first. Think of a sequence of events. There was a first event that led to a second event that led to a third event. So the definition of a sequence in the mathematical sense is very similar to the definition of a sequence in our daily use sense. Let me grab my pen right here. All right, so I'm on to my second goal, and our second goal is going to be to find terms using an explicit rule. So an explicit rule is a really fancy way to say an equation. Or, that's basically it. So right here, this example, this is an explicit rule. Okay. And I can find terms by picking position numbers. So if I want to find the first term, I plug in 1. So the first term, plug in 1. All right, so I get F of 1 equals 2 times 1 squared plus 3. So remember we have PEMDAS, so I go parentheses, there's nothing I can do in the parentheses, exponents. 1 times 1 is 1 because that's what 1 squared is. So I have 2 times 1 plus 3. So I did the exponents. Now I do the multiplications and divisions. So 2 times 1 is 2. I'm going to add that to 3, and I get my 5. So that would be me finding the first term using an explicit rule. Remember, I just plug in the position number I want. If I wanted to find, let's say the fourth term, I would plug in 4, and I would work it out. So let's see here. So that becomes 2 times 4 to the second power plus 3. 4 to the second power, that's 4 times 4, so that becomes 2 times 16 plus 3. 2 times 16 is going to get me to 32. 32 plus 3 is going to get me to 35. So my fourth term created by this explicit rule is 35. Right, I should just write that off in sense. F of 1 equals to 5. So my first term is 5. My fourth term is 35. So one more thing I want to point out about explicit rules, and this is really important, is they can find any term at any time. Okay, you can find any term at any time. All right. So let me write that down somewhere with a marker that's going to show up. So explicit rule, I want to make it very clear that we can find any term at any time. Okay. We can find any term at any time. All right. So I want to check off the third or the second goal here, and I'm going to do some video editing and come back and do the third goal. Ooh, ooh. Magic of editing. We're back to the lesson. Okay. So here we go on to our third goal, and we're gonna I'm gonna make some additional observations about sequences and relations. So what I want to point out to you basically is that sequences are relations. And so everything a relation does can be applied to a sequence. So sequences are relations. So remember, relations are a set of ordered pairs where an input goes to an output. You have an x value, you get a y value. But we don't use x and y, we use n and f of n, right? But all the inputs, we're calling those the n's. Those all together are the domain. All the outputs, which we're calling the f of n's, or the terms, and these are the position numbers, but the terms, all the outputs together, or the f of n's, this is the range. Okay, so my position number, these are the inputs. My outputs are the terms. Remember, relations can be represented as ordered pairs, tables, graphs, a mapping diagram. All the examples of sequences I've given you so far have been a table, which means that you can rewrite them as either ordered pairs, a graph, or a mapping diagram. So please keep that in mind. You're actually going to be asked to do this in a homework assignment. I have one more observation before I end this lesson. And this observation is about this example I just made up. And this problem, I gave you an explicit rule. And the sequence is going to be created by this explicit rule. F of n is equal to 2n plus 5. So there's literally two questions that I can ask you from this equation. The first question is I can find the term knowing position. The second question is I can find position knowing term. So I'll work through this one real quick. All right, so I'm going to ask you to find the third term using this explicit rule, and it's really easy to do. So let me get my marker. So I'm just saying plug in 3, right? Plug in 3 for n. So f of 3 is equal to 2 times 3 plus 5. So 2 times 3 is going to give me to 6. 6 plus 5 is going to give me to 11. So my third term, created by this explicit rule, is 11. All right, so that's how I find the term knowing the position. I just plug in 3. This one's going to give some of you guys a hard time, and here's why. I'm telling you the term. I'm telling you what f of n is. I'm telling you this, which is this. Excuse me. So I'm going to replace f of n with 15. So my explicit rule is going to turn into, I'll write it out like this. F of n equals 2n plus 5. But I know what f of n is, it's 15, so I'm going to replace f of n with 15. And now I'm going to solve for n, so let's use our 6 steps, minus 5, I get 10, 10 is equal to 2n, divide out the 2, that means that n is equal to 5. So, 15 is my 5th term. Alright, or 15 is 15 is my 5th term. So I wanted to talk about that real quick. That's going to be the last type of problems that we see. Again, I hope that everyone's doing okay out there. And again, if I write it, you write it. And have a good day, everyone. Bye-bye.